Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Devin. Hey, thanks for joining us on this wonderful autumn Wednesday here in Bakersfield. And we've got wonderful guests. We've got a wonderful visit that Scott's going to check us in with to take a look at how math is applied to some of the fields of engineering and architecture. But for now, you've got homework problems and we've got the solutions for you. So if you've got those questions, give us a call here in Bakersfield at 636-4357. If you're calling us from the San Luis Obispo area, don't want to leave you out. That number for you is toll free at 1-866-636-6284. You can also email your questions to us at dothemath@kern.org. You can watch us online at dothemathonline.net. And make sure you look out for us on social media, on Facebook, Instagram, Twitter, YouTube. We've got you covered. Join us for the show today.
All right, you know what? There are a lot of adults also that have been emailing lately with problems because sometimes they're going back to school and may have forgotten some of the things they did when they previously were in high school or college at that point, and going into different careers and things like that, getting ready for placement tests and things like that. So as always, everybody of all ages is welcome to use Do the Math. As Devin said, we have a very special guest in the studio. We'll get to that young lady in a little bit. But first, let's take a look at today's Math in the News. All right, so November 7th, and I take it you went out and voted yesterday. We talked about voting yesterday in the elections and things like that.
I got mine done in the mail, so I didn't get the cool sticker. I had to make one myself.
I know, I didn't get a sticker either. I've been doing the mail-in ballot for the last bunch of years.
So I had to get like a work label and just stick it on myself like a chump.
But we were talking about how there were a lot of elections that actually were decided by one vote, especially in the House of Representatives and things like that. And so there's a lot of things that people don't realize affect the outcomes of, things are connected in ways that people don't see all the time. And what we're going to take a look at today is one thing, and today is the anniversary.
Oh, happy anniversary.
Of this collapse. Well, it's not a happy anniversary to anybody, but it's not.
Listen, I should wait.
You know what? And it's not a tragic thing because there was no loss of life.
Okay. So
that's a positive thing here. But we're going to go back to 1940, November 7th, 1940. And so if somebody was born that day, they'd be 68 years old, 78 years old right now.
Oh, wow.
So I know we look a little older, but we didn't.
You can combine us. We can get to 78.
Oh, we'd be way over 78 by then.
I'm trying to put on an image here. We're doing great.
So let's go ahead and take a look at the video.
Love the music.
Dawn of a fatal day, and the wind begins to speak with a roar that no man can fail to hear.
Oh, it's roaring. Oh.
In a 40-mile-an-hour gale, the center span weaves like a ribbon in a swinging twist that you wouldn't believe possible unless you could see it as you do now. There's an automobile caught on the heaving roadway. The 11,000-ton center span twists and strains the giant cables that support it. Cables of 6,300 wire strands, each 17 inches thick. Back out of the danger zone, all stricken spectators are driven to safety as the bridge gyrates like a nightmare high above the river, twisting, turning, curling.
Now, I like to listen to the narration, so I don't want to step on this guy a lot, but it seems to me that people are very casual.
Yeah, like there's a giant trampoline bridge behind you about to collapse, and I don't know, Babe Ruth ran pretty fast. It could be just the speed of film back then. Oh!
Will he heed the last warning or perish with the doomed structure? But he saved himself.
This guy
5
walking,
seconds.
I don't believe this. This man in his car being left behind.
No structure of steel and concrete can stand such a strain. Steel girders buckle and giant cables snap like puny threads. There it goes! Engineers are divided as to the cause of the disaster. Some claim it was the use of solid girders. Others differ. But whatever the reason, Tacoma will rebuild. This time a bridge that will not provide a super thrill in the news.
And that right there is the Galloping Gertie, is what it was known as. And they were talking about some of the theories as to why that happened. So there's one right over here about the solid construction underneath. So in ordinary bridge design, you can see the wind is allowed to pass through by using trusses. So you can see the trusses underneath on the left-hand side. In contrast, the other one did not have that. It was solid for 8 feet right there. So you can see the different designs with the two bridges, and that was the main theory as to why that bridge went down.
The idea that those flat sides act almost like a sail catching the breeze.
So it's going above and under.
Right. It's
So
kinda
that
like how an
therefore is
airplane
causing
wing.
the twisting. So just like an airplane wing, but a whole lot thicker because you've got 8 feet right there as opposed to the trusses. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. In studio with us right now, we have a very special guest, Maryam. How are you today?
I'm good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Leo B. Hart Elementary, and I'm in 6th grade.
Home of the Hawks.
Yeah.
How long have you been a Hawk?
7 years.
7 years. All right, so you've been there quite a long time. What will you miss when you leave next year? You are leaving next year, right?
Yeah.
Okay, I was going to say, all right. What will you miss the most?
The teachers that I've had.
So they've been pretty good.
Yeah.
What thing, because I asked this yesterday of a young lady, if you could improve one thing, like if on your way out, your principal says, listen, Maryam, you've been here for 7 years, you know the school very well. If we could improve one thing, what would you like to improve at your school?
It's a hard question.
Money's no object, whatever thing that you think would benefit the school. So it would be like your gift to Hart after being there for so long.
Better cafeteria food?
Well, you know what? It is pretty good, isn't it?
It is.
But you would like to see some more and a different variety?
Yes, in a different variety. Because, like, every day, like, you've had it before at the school.
Well, they rotated it around.
Yeah,
right?
they rotated around. Just something
Now, do you have a
different.
salad bar at your school?
Yes, I do.
And you partake in that
Yeah.
every day? You like that stuff?
Yeah.
That's pretty good for you. You know what? We're going to have you do one fast problem before we go out and
Okay.
visit with our architect friend today, all right? So
Okay.
head on over to the board. What I'd like you to do is write the number 4 on the board. This is a little something we're doing with a lot of the guests that come in.
Okay.
To the left of that, write another 4. Okay, and to the left of that, write another 4, but you're going to the right of them.
Oh.
They all end up to the left of each other eventually.
Yeah, so you can go ahead and put that 4 there,
Yeah, let's finish that 4.
and put another 4 to the left of all of those.
There we go.
Now you've got it. Now, in between each of those, you're going to put an operation, a symbol. Addition, subtraction, multiplication, division, whatever you like. Any math symbols you like. Parentheses, decimals, anything is go.
Okay.
what I'd like you to do is at the end of the last 4, put an equal sign. And what I'd like you to do is choose a number between 0 and 10.
Okay.
And then you can write the number up there. So you need to get 4 4s equal to 9. So you can add, subtract, multiply, divide, use parentheses, any math symbols you like.
Arrange them
Now there
however
are a
you
lot of different ways to get 9, and I just need you to find one way to find 9.
So she starts off with a plus symbol, combining the first 2 4s. So she's starting off with 8. What is the challenge you're starting to run into now?
That you can't make 8.
Well, think, you've got 8. How many more do you need to get to 9?
1.
Okay, so you have 2 4s left. How can you use 2 4s to get to 1?
Divide it.
So we have 4 divided by 4. That's going to get us to 1. We have our 8. We have our 1.
And then you add those.
Now, is it clear that this will end up following those order of operations? Because we have 2 different operations we're looking at here. Is there something we could do to help?
Add parentheses.
Okay, where would you add parentheses? Okay. Having a second set there to make sure that we're very precise. So if we do both of these on their own, we have 4 plus 4. We have 4 divided by 4. We have 8. We have 1. 8 plus 1.
9.
Sounds good, Maryam.
There you go. Nicely done. You can go ahead and leave that on the board and leave that up there for a few moments,
That's
because
keeper.
right now we have an opportunity where we're going to go out, visit with Scott, and we have an architect with Greg Frank.
Hey, thanks, and here we are in the real world doing some math. We're live here at Skarphol Associates, and we wanted to talk about some architecture today. So we have our friend Greg Frank. Greg, thanks for being with us today.
Yes, thank you for
Appreciate
having
it.
me.
Can you tell us a little bit about architecture? What do you do on a daily basis?
Well, on a daily basis, I actually am a problem solver.
Hey, that's what we like to hear.
Yeah.
Lots of that happening in the math world.
So I take problems that people may have as far as building designs, interiors, and I'll take a program based on maybe the number of people an office or a warehouse might need, and we'll actually put together a space plan and design a building for them.
Right, gotcha. So this obviously takes some training.
It does.
What kind of education? Hopefully you're going to say math, right?
Math.
There we go.
Yeah, I actually specialized in math
Okay.
when I was in high school and college, and once I did get into college, I decided to transition into architecture and engineering.
Okay.
I stayed with engineering for a while, and then decided I liked the artistic aspect of architecture, and
Right.
So that's why I went into
Gotcha.
design.
So when you were in school, in high school, junior high, whatever, did you ever see yourself becoming an architect? Was that a dream of yours, something that maybe you thought you could do?
You know what it was? I actually loved building design. I used to design golf courses as a kid.
Oh, really? Okay.
I love to sketch and draw a lot.
Okay. So that's definitely part of it. You got to have a little artistic side to you.
Yes.
You got to have a creative side to you. But of course, there's a math component there as
There's
well.
a big math component.
Yeah. So how long have you been doing your current job?
I have been in the architecture field for 20 years now.
Wow. Okay. So that's quite a while.
Yeah.
And part of the architecture field isn't just drawing pictures, and it's not just looking up numbers, and it's not just measuring things out. You really have to have a lot of background knowledge, right? Can you tell us a little bit about the rules and the regulations and the codes you have to know about?
Sure. So our industry is heavily regulated with building codes.
Right.
We have a set of codes that I would say is between 1,000 and 1,500 pages long.
Wow.
We have not only a building code, but we have mechanical code, plumbing code, elevator codes. There's a code for just about anything you can think of.
And that seems so overwhelming, but there's a reason for that, right? There's
Sure.
a reason that all those codes exist.
It's essentially to protect you and me.
Okay.
Yeah,
Right.
it's
And so we're talking about safety.
That's
So I would love to go in my backyard and build a wonderful structure and less expensive than hiring someone to make a plan. But what's the problem with that if I just go build something randomly that looks nice, but maybe isn't up to code? What are going to be some of my issues?
Well, there could be multiple issues. You could build a structure that's too big, and maybe you create some spans between posts that are too long, and you could have a roof collapse.
All right, that'd be bad news.
That would be bad news. Sometimes you might use the wrong materials. And let's say you use a piece of wood and bury it in the earth. Eventually, the soil and pests are going to eat that, and it'll rot, and that could cause damage as well.
Right. So you have to take all these things into account, rules and regulations, but not only what the structure is going to look like, but what it's going to be made out of. Right. So you have to have a plan.
That's correct.
Right. Can you show us a plan? What's a generic plan that you might start off with when you're looking at a project?
Well, I'll show you. This actually here is a set of drawings, and so this is what we would produce to give to a general contractor so they could go out and physically build the buildings. This is essentially the instruction manual for putting our building together.
Right, and there's a lot of information on here. So when I, as someone who comes to you and says, I'd like to build this structure, and you say, okay, here's the plan, what's the first thing you're going to show me on this plan here? What am I going to look at that's going to make the most impact on my project that I have in my mind?
Well, first things first, this set of drawings here is comprised of multiple disciplines.
Okay.
So not only do we have architecture, but there's structural engineering, we have plumbing, mechanical, electrical engineering. We have a civil engineer who determines slopes and grading for a site. They deal with drainage as well. And then we'll have landscape architects that help out with our planting and trees.
Man, there's so much that goes into putting a building together. Because I think of, when I want to see a plan, I think of a blueprint, right? Or a top-down rendering of a building.
Correct.
And that's certainly part of it.
It is part of
But
it.
there's a lot more to it. I mean, even the first page, just kind of like the first page of a textbook, is
Yeah.
kind of like an explanatory page, right?
So one of our sections on our title sheet is called a project analysis. And we will list different aspects of the building, like the size of the building in square footage. We'll also do an analysis for determining the number of plumbing fixtures.
Good deal. Man, that's so much to look at. And your basic way that you measure most things, I thought this was a wonderful replica here, right? Wonderful idea of what a square foot is. Because when we talk about area, even in an elementary school classroom, we want to talk about square footage, right?
Yeah.
And this is it. This is 1 square foot. That's how big a square foot is.
That is
You can
it.
see here, right, with the ruler, there's 12 inches, and there's 12 inches up here. So
Yeah.
there's 1 square foot. So when you're talking about a room that's 200 square feet or 300 square feet, there's a whole bunch of those. It's
Yeah.
awfully nice when I go to a room that has nice 1 square foot tiles. It's easy to tell my students exactly how big the room is.
We also look at the ceiling. 'Cause
Oh, we got ceiling tiles
generally
too. That's right.
The ceiling tiles are maybe 2 feet by 4 feet. So
Okay.
we use that as a unit as well.
There you go. Well, we got lots more to talk about. Thanks for the introductory information. We want to make sure that we get to some more renderings and some real life things, maybe even in 3D. But we know there's also some more to do back at the studio. So back to you, Mike.
All right, thanks for that, Scott, and also thanks to Greg out there. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we're going to go to the phones and a repeat caller from Reagan Elementary. Caitlin, how are you? Hello, Caitlin. And perhaps Caitlin is not on the phone right now. So here's what we're going to do. We're going to put you back up on the board again. All right, so go ahead and put your 4 4s. Oh, you know what? Oh, hold on a second. I think we've got Caitlin. Caitlin, you're on the phone?
Yes.
All right. How are you today?
Good. How are you?
I'm wonderful myself. And Maryam, say thank you to Caitlin.
Thank you.
Because you just saved Maryam from having to do
close.
the most difficult problem in the entire world.
We almost had her,
which is
Caitlin.
what we were going to do
Almost.
with her. But Caitlin, as soon as you're ready, let's hear the math problem that you're working on.
4 open parentheses, c plus 3 close parentheses minus open parentheses, c minus 1 close parentheses equals 64.
So these are both C's, correct? Both variables are C. Is that right, Caitlin?
Yes.
Okay. Well, that makes it nicer because that would be a very challenging approach if they were 2 different variables. So it looks like we're going to have to find the value of C in this expression. And we got a couple of things that we have to navigate through. We have the variable showing up a couple of times in two very different sets of parentheses. And then we also have a coefficient of 4 tied to one of them. So where would you like to start off with this?
So I first did a distributive property, and I did 4C plus 12.
Okay, so you're going to distribute that 4 into the C plus 3, because we essentially have 4 of these sets of C plus 3. We're going to end up with 4 C's, and we're going to end up with 4 3's as well, which is 12. So we have 4C plus 12. All right, so we have 4C plus 12 minus parentheses C minus 1 equaling 64. What do you think is the next obstacle we need to overcome here?
I did the distributive property again, and then I did minus 1C plus 1.
So we're distributing this minus symbol, and it's a lot of times very challenging for many people to do that. What you really have to consider is that this is the same thing as a negative 1. So we'll just kind of throw that in there as a reminder. So we're going to distribute negative 1 into the parentheses. And you said you got minus C plus 1, because negative 1 times negative 1 is positive 1, correct?
Yeah.
So we have 4C plus 12 minus C plus 1 equals 64. So it looks like now we're at the point where we can start combining like terms.
Yeah.
So let's go ahead and start doing that. What terms would you like to combine first?
4C minus 1C equals 3C.
So we have 3C plus 12 plus 1. Those two seem like they're pretty straightforward to combine.
Equals negative, I did equal 64 minus 13.
Okay, so 12 plus 1 is 13, and now we have that 64. We're going to subtract 13 from both sides, including that 64. So 64 minus 13.
Can I move that screen down a little for you?
There we go. Yeah, be greatly appreciated. So we subtract 13 from both sides. We are left with 3C equaling 64 minus 13.
51.
Now we have 3C equals 51. How do we isolate that variable? How do we get that C by itself?
Divide by 3.
Okay, so we're going to divide both sides by 3. 51 divided by 3. It's not one of those friendly facts that we find on the multiplication table. What is your approach with 51 divided by 3?
I divided it and I got 17.
Did you use the long division bracket to do that? Because some people, 17s is not a very friendly fact family. Sometimes the 3s, we usually get stuck at around 36, but you keep going. Ultimately, you figure out that 17 times 3 equals 51. So that tells us that C equals 17. And then we can plug that back in to the original once we check it out, time withstanding. And there we have it. Nicely done, Caitlin.
There you go. Great problem. And while you were doing that, Maryam was in studio working on that, got 17 as well. And Caitlin, if you're still on the line, congratulations. You've got yourself a pizza, courtesy of our friends at Cubby's Pizzeria.
You see that giant thing roll by?
Congratulations on that. It's going to roll right on by and into my belly is where it's going to go. I'll eat that whole pie. Now, do you like the Chicago-style pie?
You got to eat that with a fork and knife, right?
Yeah,
I don't know.
Most do. You know, and I mean, because we're both New Yorkers and
right.
we prefer our slices the proper way. But Cubby's does have a variety of pizzas and a variety of pies. So I do like all of their pies they have at Cubby's.
I really do have to make a visit over there. I've yet to do so, and I think it's on my list.
Really?
Right? Really. Swear. I've got to make it happen.
Well, you know what? Let me know. You can treat me to some pie also. We'll go.
Like
you like pizza pie?
Yeah.
Do you have a favorite? Do you like the thin style or do you like the thicker one, the Chicago style?
I like the Chicago style.
What do you get in that thing? Do you put what certain toppings?
I
Fillings,
get-
I guess.
I get cheese, olives, pepperoni, and sauce.
Yeah, pack it in there, huh?
Yeah.
All right. Well, you know what? Let's get you to work so you can possibly get yourself a Cubby's too, all right?
Okay.
Back to the board. Clear enough.
Here we are.
Here we go. Here's one of the problems that you're working on. So let's go ahead and take a look at the figure together. So you've got a triangle, and you guys can start putting this up on the board if you like. You've got a triangle. It measures 36 meters as far as the height and the base.
Okay.
And inside of that, you have a rectangle that is blocked off, and it's 9 meters high and 27 meters across.
Okay, so I don't want to use that rectangle. We have a rectangle that kind of splits this triangle into two smaller triangles off to the side, and it's 9 high. The whole triangle is 36 meters across.
And the top of the rectangle is 27 meters.
And the top, so it's a rectangle that is 27 meters long.
And you need to find the area of the shaded part. And the shaded part, and it might not be easy for some folks to see, but it is the part where the triangle is. The part we're taking out is the rectangle.
So we have to find out this area. And again, this is a triangle that's 36 meters tall. And we're trying to find this whole area here with that rectangle removed.
Yes.
So there's a couple of things that we need to keep in mind. What information do you think is necessary? What do you want to start off with to help us find that shaded area?
I would start off with first finding the area of the whole triangle.
So we're going to start off with the whole triangle, and we have some information that's going to help us out. So what information do we use to find the area of this whole triangle?
We would use the base.
Okay.
And the height.
So we have a base of 36 and a height of 36.
Yes.
So what do we use? What do we do with that information?
We multiply it together.
So you're going to multiply that together. Okay, we have 36 times 36. We're going to square 36. Do you like using algorithms with multiplication, or do you like using area models?
I like using algorithms.
All right, do you want to work that out? We'll do 36 times 36 then. So we're going to start off multiplying the ones column. We have 36. Throwing a 6 in the ones column. And then we'll put a 3 up as an additional set of tens for that sentence. So we have 3 times 6 for 18 tens, plus 3 more tens, that's 21. So we have 216 for the 36 times 6 component. We're going to do the same thing with the tens now. Multiply 3 tens by 36. Starting off with 18, bring a 1 over into that column. And 33s is a 90 plus 3, so we have 10. So we have 1,080 for that second part. So we have 216 plus 1,080. Adding those two together, we're going to end up with 1,296. So 1,296, that's the area of our triangle? Or are we missing something yet?
We are missing something.
So what do we still need to do here?
We still need to divide it by 2.
That's right, because we essentially found the area of a square that is 36 long and 36 wide, but a triangle is half of a square, so let's find half of that. So 1,296 divided by 2. These usually work out pretty efficiently and quickly when we divide by 2 with that division bracket. Yeah, we can get 2 into 9 4 times.
Yeah.
There's going to be something left because this is going to be, a 9 minus an 8. So we still have 1 10 left, and so we'll have 16. 2 can fit into 16 8 times. So we know that the area of that triangle is 648, what do we call that unit?
Meters squared.
Meters squared, right. We want square meters since we're dealing with area. Great, we found the area of the triangle. We still got to do some things.
Yeah.
What's next?
We have to figure out the area of the rectangle, then subtract that by the area of the triangle.
So we're going to find the area of the rectangle and kind of cut that out of the area of the triangle. So how are we going to find the area of this rectangle here? What information do we need to use?
We need to use the 27 meters and the 9 meters.
Okay. And so we have 27 meters long, 9 meters wide. What do we do with that information?
Multiply.
We're going to multiply. We're going to go ahead and algorithm that out again. Let me give you this space over here.
Okay.
All right? Don't worry about these rectangles down there. We're going to do a 27 times 9. Very straightforward compared to the last one. 63 for 7 times 9. And we bring that 6 over into the tens column. So we're going to do 9 sets of 2 tens, 18, plus another set of 6 tens for 24. So 243 square meters for that rectangle. Great.
Yes.
So we have the area of our rectangle. Now you mentioned that we were going to do something with that.
Yes, we are going to subtract it from the area of the triangle.
So let's subtract. We've got our larger triangle of 648 and our smaller rectangle of 243. Mind that line. You will not be a fraction today, but we're going to subtract with this. So what does this number represent?
This represents the area of the triangles with, well, no, that represents the shaded area.
I kind of see what you were saying, though, because we essentially have 3 triangles here
Yeah.
that create an area. And it almost makes me wonder if there's a second way that we could have done this. Without going through all the work, how else could we have figured out the area of that shaded piece?
And
I
that,
didn't know
my dear
that.
friends, will be something for you to ponder.
Okay.
All right, so you can take a look at that, ponder that. And we do have phone tutors available until 5:30. They'll ponder that, and we'll be back with more right after this. Today we're at Midway School, home of the mighty Midway Tigers, and we're here to Well, today we're at Midway School, and we've got some 5th and 6th graders ready to work on some math problems, and we'll kind of work on them together, and then everybody else can see how these kids are working on some math. You guys ready?
Yep.
All right, here we go. So, first of all, who knows what an integer is? What's an integer? What do you think it is? On the spot right there, huh? All right, you know what? Let's go over here. Some of you girls had your hand up. What's an integer? You guys know what it is?
It's like an opposite of a whole number, so like -1, -2, -3.
Okay, so -1, -2, -3, those are all integers. Could 1, 2, and 3 also be integers?
Yeah.
Yeah, they could, right? It's just that we have some that are negative and some that are positive, all right? So when you're thinking about integers, you're thinking about whole numbers, okay? So, what is the main number that differentiates positive and negative? Where do you start from?
0.
0, right? A lot of people think 0's not got much use because it's just 0, but it actually has a lot of uses, all right? So we're going to start at 0, and if we go to the left of the number line, what are those numbers?
Negative.
Negative, and to the right is
Positive.
positive. So we're going to add and subtract. So you guys are in 5th and 6th grade, so you've added and subtracted negative and positive numbers before, right? And you've multiplied and divided with them also? So we're just going to do a little review on that a little bit, okay? So on your papers, and you guys are going to come up, you're going to make the math problem, all right? So how about if you give me a whole number, positive or negative, doesn't make any difference.
5.
5. Positive 5 or negative 5?
Positive.
Positive 5. All right, so we'll put 5. Would you like to add or subtract after that?
Add.
Add. All right, so you guys are writing this down as I'm doing it, all right? So we're going to go 5 plus, and give me another number. Positive or negative makes no difference.
3.
Positive or negative?
Negative.
Excellent, we've got -3. So we're going to go 5 plus a -3. And would you like to add or subtract after that?
Subtract.
Subtract. All right, ladies, somebody give me a number. Positive or negative?
8.
8. Positive 8?
Yeah.
So we're going to subtract 8. And do we want to add or subtract after that?
Add.
Add. And one more number. First one that says the number gets it.
6.
6? Positive or negative?
Positive.
Positive 6. All right. So here we go. We'll just start off with this. So we've got some numbers in here that are positive and some that are negative. You all agree on that? All right. So what I'd like you to do is go ahead and figure out what that would come out to be. So we have 5 plus a negative 3 minus 8 plus 6. So you can work on your own. You work together. See what you're going to come up with, and we'll see if everybody has the same answer. And if you do, we'll see how you came with that. And if not, we'll see why or how we have different outcomes. All getting answers here so far? All right. Let's go ahead and see what we've got. So does anybody have an answer? What have you got?
0.
0. How many people agree with him that he's got 0 and that's what they've got also? And some of you are still working on it, that's fine. So it looks like you all came up with 0. So explain to us how you got 0, because you got 0. Let's see the process you went through.
What I did was I remembered that if you add a positive and a negative, it turns into a positive. So I got positive 2, and then I subtracted 8 from that and got negative 6. And then I added 6 to that, which would make it 0.
There you go. So you went 5 plus a negative 3, and since since the positive number is larger, it's going to stay positive.
Yeah.
So 2 minus 8, the 8's larger, so the number is going to be negative when you have that. Negative 6 plus 6 comes out to be 0. Nicely done. You know what we're going to do? We're going to see some other ways to do this the next time we come back and put forth a little challenge to you guys at Midway School. And again, a big thanks to the staff and students at Midway School. We had a great visit out there. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. We have Maryam, a 6th grade student from McAuliffe Studio. But right now we have another opportunity to head out. We'll check out with Scott and our architect, Greg.
Hey, thanks, Mike. We're back here live at Skarphol Associates, talking a little architecture today. And Greg's going to show us a little bit more about making some plans when you want to make a building. So, Greg, can you take us through? There's two different, we've been talking a little bit about, there's two different projects that you can do. You can do a brand new project,
Right.
or you can take an existing structure and do some things with it to change it around, right?
Yeah.
So let's talk about that second situation first. If you have an existing structure and we need to change it, what goes into some of that planning? Can you show us a little bit about that?
Sure. I'll show you here on this set of plans. So this project actually is quite unique. It was it's two buildings on one site that the client wanted to join together in order to add more office space.
Right.
And so I will open this up to a site plan. So this is a site demolition plan.
So this is the current way it looks, right? You have two different buildings.
Correct. Yeah, so this is the existing conditions. This plan here actually is scaled at 1 inch per, or equals 20 feet. So every inch on this drawing would realistically scale out to 20 feet.
Okay.
But what we've shown here is with these dashed lines, these will represent sidewalks, trees that are going to be removed in order to make way for a new structure.
Right.
And so we have existing building 1 and existing building 2. And on the next drawing here, this is a different scale now, so we're at twice the scale. It's 1 inch equals 40 feet.
So it's almost kind of like we've taken the overhead view and panned out a little bit, right?
Correct.
To get a picture of more of the land area.
A little bit more of an enlarged view.
Right.
Correct.
But the picture ends up being smaller because we're showing more land area.
That's correct.
Yeah, okay.
So what we have shown here is the first existing building.
Right.
And the larger second existing building, and then the dark line here will represent the new addition where we're joining these two buildings together.
So the ultimate goal of this specific project is to bring two buildings into one big gigantic building, right?
That's correct.
Gotcha. And so along with doing a project like that, you have to talk about and plan out what that new building is going to be like, but also adjust and modify the current buildings, right? So there's
Correct.
two parts to that. Well, I'm sure many parts, but at least two main parts to it.
Yeah. Well, and there's a few other things we have to look at. Because this was a building addition, it requires a few additional things to think about. So one of the things is additional parking.
Oh, that's a good point. Totally practical.
Yeah, all buildings require a certain amount of parking, and it's all based on an equation. So
Okay.
this building is an office building, so for every 250 square feet of building, we actually have to add one parking stall.
Okay. So there really is kind of an equation or a formula to do that.
That's correct.
Yeah, and I'm sure there's a formula for the amount of restrooms you have to have, right? And the amount of exits you have to have in and out of the building. All those things are going to be based on a real strict code,
Yeah.
right? And you can figure out those numbers using a specific formula, right?
That's right.
So a little bit of math going on there.
A little bit of math.
All right. So can you show us a little bit about what you might do to an existing building? I think we have a picture of that as well, where you're going to modify the existing building and move some things around. And
Yeah, so next sheet here would be a demolition plan. So
Okay.
we have actually a set of existing toilet rooms that probably didn't meet code. Maybe they weren't large enough for this use. So we proposed to demolish all of the toilet fixtures and some walls to make way for the new set of toilet rooms. And so this here is our final floor plan. It shows the layout of the addition and then our new fully up to code toilet rooms.
Right. And so this brings the two old buildings together, along with the brand new building, into one entire building. And so part of your job, it seems to me, is not only exterior, right, and also the structure part of the building, but you have to plan and do some interior decorating as well, right?
We do lots of interior design.
Yeah.
Yeah, so not only do I get to play with the shapes and sizes of offices, but we also get to pick the colors and types of finishes as well.
All right, good deal. So you get to be awfully creative.
Awfully
Gotcha.
creative.
Okay, so this is an existing project that you had. What if we want to go to a brand new one, right? So we have some bare ground and we want to build a brand new building.
Yeah. So this project here, this is actually a site plan of the existing Hoffman Hospice facility out on Buena Vista Road. And we have their existing hospice building here. And what we've done is proposed a little more than a 10,000 square foot building for them. And so that's what we have shown here.
Gotcha. And so there's kind of the outline and how it falls on, where it falls on their property, current property.
Correct.
You can see obviously there's some parking here. But then once you look at that brand new building and where it's located on the property, we have to talk about some details, right? So then we have another picture that can show us what the interior would look like of that brand new building. And that's an awfully busy picture.
This is a busy picture. Yeah, it's very technical, but it does show the shapes, sizes of offices, relationships of their open workstations to where the entry is or the break room. Also, we've detailed out their toilet rooms as well.
And you can see all along the bottom we have measurements for every line between each different place, each different measurement, how big the different rooms are and how long the walls are and all those things. And there's numbers just all over the place on this drawing.
Correct, yeah. So our dimensions, a contractor will be able to use out in the field, and this will tell them how big the structure is or where bearing walls or columns are located.
Right. Well, we certainly love to see these pictures, and they have all kinds of numbers on them, and they're wonderfully creative. But we still want to see the 3D version. So when we come back next time, we're going to be able to see the 3D version of a picture when we have the overhead view, have the drawing, but what does it really look like? Right now, we'll go back to the studio and do some math on the board.
All right, thanks for that, Scott. We have Maryam in studio, and we're going to do another problem with Maryam. And first of all, do you know the difference between a profit and a loss?
Yes.
Okay, can you kind of explain what you know about that or what you think the difference is?
I think a profit is something that you gain and a loss is something that you lose.
Right. So you're going to need that knowledge for this next problem.
Okay.
Head on over to the board. We'll take a look at it together. So a bookstore had a first quarter profit of $342.60.
Could you do me a favor? You've got the black pen. Could you write the profit in black, just for the sake of organizing?
So $342.60. All right, the next thing, a second quarter loss of $78.35.
I'll write this in red for a loss.
$78.35.
The dreaded red pen of school.
A third quarter loss of $127.40. And a fourth quarter profit of $457.80. Did the store make a profit during the year? Explain.
So something to keep in mind is the ultimate question that is being asked.
Yes.
Could you go ahead and just read that question one more time? Just the question piece.
So did the store make a profit?
So what's nice about this is we don't necessarily have to find a precise answer in the form of value. We just have to be able to represent why we could tell a store is making a profit. So looking at these values, what are your thoughts?
I'm thinking right now that the store did make a profit.
And what's your reasoning there?
Well, because the loss is less than the profit.
So just on observation, using your number sense, the profit totals seem to be greater than the loss totals.
Yes.
What is another, so like how else could you explain that using the numbers given? Or how could we show that or prove it or explain that why that's true?
If you take one of these, like example 457.8
Okay.
cents, and add these together and subtract that to this, I believe that would be less.
That's fascinating. So you're saying if you combine all the losses, it still doesn't even total up to the lowest or even the highest of one of your profits.
Yes.
And then when you add the other profit on top of that, it's much greater.
Yes.
I mean, you could even look at a direct comparison going across, right? If this profit is greater than this loss, and this profit is greater than this loss, then the total of this profit has to be greater than the total of this loss.
Yes.
Now, we should probably, if we're going to be diligent and precise mathematicians, we should probably figure out what these totals are, huh?
Yeah.
And I'll give you guys 30 seconds to do that.
Oh, he's giving us 30 seconds. We got to do this fast. You do the profits, I'll do the losses. Algorithm, up and down, carrying numbers. Okay. All right. Okay, we have another 20 seconds, so what should we do with this 20 seconds of awkward time? Let's explain. Well, do we need to subtract? Because, like we said, we know what the profit is,
Yes.
and we know what the loss is.
Yes.
Are we going to end up with more profit or more loss?
More profit.
So if we know that we're going to have $800.40 of profit, even if we think about an estimation, like round this to 200 and take 200 away, we're still going to end up with a positive value instead of a
Yes.
negative. So, I mean, using your reasoning, we're going to have a profit here.
There you go, nicely done. The reason I only gave you 30 seconds on that is because I've got another problem for you that is going to deal with stocks, because I understand you're working with the stock market in your classroom.
Did you know he was
All
going
right.
to do that? He kind of did. Yeah, that's right. That's right.
All right, clear the board, clear the board.
Here
Here
we
we
go.
go. Let's take a look at the next problem. The price of a share of stock increased $3 on Monday, decreased $1.25 on Wednesday, and decreased $2 on Friday. Find the overall change in the price of that stock. So on Monday, it increased $3.
Ooh, which one of us should write the increase? You've got the black, I've got the red.
I'll do it.
Do it. Okay. She said she's going to do it.
Decreased $1.25 on Wednesday.
Does that mean now?
Yep.
I'll do that. So decreased $1.25.
And then on Friday, decreased another $2.
Down another $2. Okay.
Now we do need to find the overall change.
All right. So we have 2 decreases and 1 increase. What do you think we should start off combining?
The decrease.
Let's combine our losses here, right? So I'm just going to go ahead and add, even though we generally think of these as, losses or negative values, we can still combine negatives together.
Okay.
So I'm going to go ahead and combine my negatives. So I have 25 cents, $1 and $2. So this is a loss, a decrease of $3.25.
Yes.
Now we've got an increase of $3.
Yes.
So we're adding a positive, we're adding a negative. But when we think of stocks, I don't know about you, I like to think of a number line, like having a starting place and then tracking what that looks like. So if we start at 0 on a number line,
Yes.
and it went up, it increased $3 on one day. But then over the course of the next 2 days, it went down $3.25. What would that look like here?
I think that would look like, which that would be.
So, well, let's figure this out piece by piece, right?
Yes.
So going back from $3 to 0, what is this difference here?
The difference is 3.
It's $3, right?
$3.
So how much more do we have to go with to get to our total loss here?
$3.25.
So that would be the distance from here to whatever this is, right?
Yes.
And we've already chopped off $3 here. So we can cross that out. What's left to go back to?
25 cents.
So that puts us right here at negative 25 cents. So what does that tell us about the total change from the beginning to the end?
It tells us that you lost 25 cents.
That the value went down 25 cents from where it originally started.
There you go. Nicely done. Maryam, come on over here for a moment.
Oh, yay. That was a yay.
Yeah, I was going to say, you hit the wrong buzzer there for a moment. So you're doing the stock market game.
Yes.
Has your team profited or been making losses so far at this point, the last you looked?
We have been making losses.
Is there one company you think that has been worse than the others for you at this point?
Well,
I hope it's not any of our sponsors.
well, I think it's NASDAQ because it keeps on.
So okay.
The exchange
Yes.
itself. I see. Okay.
And what other companies do you have? Do you remember any of the other companies you guys have? One other company?
If I had my papers, I would know.
Yeah, well, you have it all in your papers and stuff like that. All right, well, you know what? So it's a great lesson that you guys are learning about how this all works and things like that. And right now we're going to learn a little bit more about the architecture and take a look at this 3D building with Greg and Scott.
3D.
Hey, thanks, Mike. We're back here in the real world doing some math, talking a little architecture, and we have kind of the classic thought when you think about what architects do. You want to have a nice rendering, right? You want to have a nice picture of what's going on. So when you think about the classic portfolio, this I thought was just such a great example of what you think of when you say, hey, look, this is what I do, right? And you can take this to your kid's classroom and you can show your neighbors, and, hey, this is what I do. This is great, right? So we have these wonderful color pictures about what it's going to look like. And then, of course, we got to talk about details, right?
That's right.
So we already talked about the blueprints, basically, or the plans. This would be an overarching plan of the whole property, and then we can go down to the building level. But really, we still are in a two-dimensional world. We still can't see around the backside or what it's going to look like with plants in the way or whatever it is. And so we have some technology, right? You have some technology to use. Can you please tell us all about it? Because we are so intrigued about what this thing does.
So we use a program called Google SketchUp.
Okay.
Cool thing about this program, it's completely free. So all of your students, can go download this, and you guys can be as creative as we are on a daily basis.
Oh, that's great.
So this project here, this is our 3D model of what is going to be the new Hoffman Hospice facility.
Okay, gotcha. So we talked about this was the plan
Correct.
that we had with the details. Where is that building here on your picture?
So this is their administration building in plan. On the rendering, that building is actually right here.
All right. Right.
So we have proposed 2 smaller buildings off to the side. Their existing building is here to the left.
Gotcha. And if you had just a regular picture of it, it'd be hard to see it from a different angle. Can you see it from a different angle now?
We sure can. So the great thing with technology is we can just spin this around and take a look at our complex from a whole new angle.
Wow, that is just amazing. It's so helpful for you or a client or a contractor or someone to get an idea what this thing is going to look like in context of what currently exists, right?
Right.
So not only that, we talked a little bit about the landscaping, right? You talked a little bit about the parking structure. How do we look at those things and how they fit in?
Yeah, so what we do is we group all of these different structures into a component or group, and so it becomes one entity.
Okay, so can we maybe highlight our building first?
Sure. So we'll take this building here with the lighthouse on it, and if we click on it, it's going to highlight with the blue box
so that
around
thing
it.
is all together as one.
That's right. So we could take it if we wanted to and move it around the site, rotate it.
Sure.
We could flip it upside down if you want.
Whoa, hey, there's all kinds of things.
Or even just a simple push of a button, and then we can make it disappear.
And it's gone.
It's gone.
Wow. So without having to actually build a building and then demolish it and then rebuild it, we can just make it disappear on the picture, and so we know exactly what it's going to look like, or at least have an awfully better idea, right?
Yes.
You also talked a little bit about how you can isolate the landscaping, right? Can you show us about kind of how that works?
I can. So if we clicked on some of the landscaping too.
Wow.
Now we can isolate just the landscape layer. All the buildings disappear, so we can easily work on just the trees and bushes and move them around.
Right, right. So helpful. So in the overall scheme of things, when a client comes in, they can have a color picture, they can have a plan, they can have a 3D rendering. Does this 3D model help you out?
It does. So not only do we use these 3D models to put together a rendering to show our clients, but we actually use this for design.
Oh, okay.
And so in-house, we'll build these models on the computer. We look at it, analyze it to see if we like the structure, like the layout, and then we'll change it probably 100 times before we even show the client.
Right, right. Save a little paper that way too.
Save a lot
Tell
of
us
paper.
just real briefly about the math that goes into the rendering.
Well, so the 3D models are actually built to real-life scale.
Oh, okay. That's nice.
We
So you don't have to
can-
worry about the scale changing on you.
We don't have to worry about the scale changing. Unlike our drawings here, the two-dimensional drawings, they are all plotted in different scales.
Right. Right.
So our floor plans here are scaled at 1/8 of an inch equals a foot, whereas our site plan was scaled at 1 inch equals 20 feet.
All right, man, there's so much, and there's so much more to talk about, but we wanted to make sure we at least gave you something, maybe be part of your next project. We always have the famous Do the Math tile. We want to go ahead and offer that to you for taking your time with us today. Thanks so much.
Thank you very
Maybe on the
much.
next project, the Do the Math tile will enter into the plan somewhere.
I think it will.
Had a great time learning about some architecture, all the different ways that we can use math and all the math that's necessary for it. We're so glad that we got a chance to be here. Let's go ahead and wrap it up back in the studio. Back to you, Mike.
All right, thanks for that, Greg and Scott. And in studio with us, Maryam, and Maryam will be doing a bit of architecture later on this year, so we're just kind of excited to see things like that. And also for doing some great work today, we'll be sending Maryam to the Bakersfield Condors to check out a game. And Do the Math will actually be at the Condors later on during the month. Devin will be out there with Mary Lou.
It's coming.
And
That's
we're
right.
going to put some skates on. You get you out there? And, no, I'm only kidding.
Oh,
But we'll
boy,
see if
I
we can
would
do
be
that during the
toast.
game.
I've been there. I'm not the roof.
Yeah, all right. Well,
Seen
you know
that.
what? We'll get the cameras out there for that one.
Yeah.
Anyway,
Won't be
did
the
you have
first
fun
time, won't be
today?
the last.
Yeah.
Good. You know what? Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.